Welcome to lesson 4. In the previous lesson, we learned that the single server architecture was expensive and less efficient when compared with the distributed architecture. Here we would look at a few other distributed architectures and understand their limitations and advantage of Hadoop over them. One of the distributed solutions which has served us well till now is the high performance computing and grid architecture. In a typical high-performance grid architecture, there are a number of processors communicating through Message Passing Interface (MPI) and shared memory. This serves well in a compute-intensive jobs in the situation where large amount of data, say hundreds of GB, is not needed. As the data size increases, the network traffic increases and hence bandwidth becomes a bottleneck. However, Hadoop's architecture is a little different. Hadoop has nodes which are just like personal computers. There is a hard disk with every CPU. Thus, every node has their own storage area as well. While assigning the task, the master node considers data locality and hence the network is used only for small update messages. The scalability is higher in Hadoop. We would deep dive in all the terminologies like job tracker, task tracker, and data locality in the next segment of the course. Another distributed computing model is the volunteer computing. SETI, which stands for Search for Extraterrestrial Intelligence, is a project which aims to analyze the radio waves that they receive from universe. They try to find a pattern, thus any trace of intelligent communication in the radio waves to infer if there is any extraterrestrial intelligence trying to communicate with us. This project asks people like you and me to download their applications which would pop up as screensavers on our computer. And so, when we are not doing anything on our computer, this program would use the idle CPU cycles to analyze a work unit for patterns, applying various advanced algorithms like Fourier transforms, etc. When the work is finished, the application on our computer would send the results and would ask for the next work unit. The central server has to distribute a work unit to 3 or more nodes so as to combat failure and erroneous results. This architecture is suitable only for CPU-intensive work which can have variable throughput time, and this can be applied only in the situations where data can be shared across the network. So this is not a viable option for the most of the business problems.